So we are starting the next chapter, fluid missions. Okay, so there are different names for this particular chapter: fluid missions, fluid missionaries, hydraulic missionaries, or turbo missionaries. There are different names. Okay, so with respect to gate, if you see, for both mechanical and civil, this is not going to be very important chapter. Okay, which means what I can say, not very important, but they could ask question. Okay, they could ask one question from this. Okay, and if you see this particular chapter itself a separate subject. Okay, so this particular chapter itself a separate subject. So we are not going to be deal with that subject completely. Whatever is required for GATE, in that point of view we will be discussing, and all the basics points and all those things, like all the basic points and whatever required for us, that will be completely covered. But we are not going to go in depth because there are different parts, and it's like a 2-3 semester course. First semester we will be studying separately some topics, in second semester some topics, in third semester some topics. Okay, and here we are going to be mostly concentrating on hydraulics. Okay, we are not going to prefer dealing with pneumatics. We are going to concentrate hydraulic machineries only majorly. Okay, so in that, what are the things which we are going to discuss, we will see one by one. Okay, before entering, what I am going to do in this video is, first I am going to define what is mean by fluid missions, then I will be classifying the fluid missions, then I will be entering into a very interesting topic like rotodynamic missions, what I mean by rotodynamic missions, and we will be discussing about principles of rotodynamic mission, and then it comes how to draw a velocity triangle, and that is where many of them are lagging, right? So how to draw a velocity triangle easily. If you follow this method, it's going to be very easy for you. I am damn sure about that. Okay. So first, in this video, let me give introduction about fluid missions, and then we will see the classifications of fluid missions. Okay. Right. To start with, what is mean by fluid missions? See, it's very simple. Fluid missions, right? Okay, fluid missions. So fluid missions, I will just represent it as FM only. So fluid missions are some missions which is going to convert either energy which is stored. Okay, so I will write it like the stored energy in fluid. Okay, so it's a mission which is going to convert stored energy in fluid to mechanical energy. Okay, just wait for a moment, let me give you the explanation. Okay, either stored energy in fluid will be converted into mechanical energy, or mechanical energy will be converted into fluid energy. Okay, so the energy which is stored in the fluid, it's a machine which is used for converting one form of energy in the fluid to mechanical form of energy, or mechanical energy into stored energy in the fluid. See, stored energy in fluid, in the sense, there are different forms of stored energy. If you take a fluid which is in static, that is, the fluid is not moving, the fluid is in rest, then I can say that there will be potential energy for the particular fluid. Then we can say that intermolecular energy in the sense, the energy which is possessed by molecules. Okay, the energy which is possessed by molecules. In thermodynamics, we would have studied internal energy, right? The same thing, intermolecular energy possessed by the molecule. Here it is not required. We are not going to go in deep about it. Okay, so we will be studying all those things separately in thermodynamics for mechanical students. Potential energy, intermolecular energy, or if the fluid is moving, then kinetic energy. Kinetic energy is nothing but energy possessed by any body which is having some velocity. Potential energy is nothing but energy possessed by the body which is placed at some particular height. Intermolecular energy is nothing but energy possessed by molecules itself. And also pressure energy. Okay, this we can say it as flow work also. Okay, what is mean by this pressure energy flow work? Don't worry about much. Okay, don't worry about this much for now, because this is not something which is required to be studied in hydraulic machinery topic. Okay, so that has to be studied separately in thermodynamics. For civil students, you don't have to worry at all. what I mean by this flow work and all those things. Flow work and intermolecular energy, just don't worry. We'll be studying about mechanical students, we'll be studying about these two in thermodynamics. Okay, so just be calm about that. But what you need to understand is, if you take fluid, then fluid can store, okay, then fluid can store energy in any of this form. Okay, so it can store it as a potential energy, intermolecular energy, kinetic energy, or a pressure energy. And the energy which is stored inside the fluid, if I use some external machine, okay, for converting into mechanical energy, most predominantly rotation of shafts with some load. Okay, so I will come for it. What I mean by that, loads. Okay, but it's very simple, right? So energy in fluid will transfer to mechanical energy, which is nothing but rotation of shafts. Or else, sometimes rotation of shafts, that is mechanical energy, will convert it back to fluid energy. I will be rotating the shafts and I will be converting it into fluid energy. Okay, and this rotation of shafts with some loads, what actually it means? Load in the sense, I will be connecting, right? Generally, what will happen, if you see any power plants, turbine will take fluid energy and it converts into rotation of shafts, and that shaft will be connected to an alternator, or you can say that electrical generator, right? So I will be connecting this, and that load, okay, the load which is carried by the shaft is nothing but electrical generator or an alternator. So both of them are same. Okay, so you can use any words. And this electrical generator will take energy, that is the mechanical energy, will be converted into electrical energy, and that we are going to use it for our purpose. Okay, so this is in fact a brief idea about machines. Okay, fluid machines. Either I will do this from this to this or from this to this. Based on that, there are many classifications. We will be talking about that in detail. Why I'm not saying now, because we will be talking about it. That's why I'm not saying now. Okay. So we will continue discussing fluid machines, and now I'm going to discuss about the classification. Okay, so still we are in the introductory video of fluid machines, and here I'm going to discuss about classification of fluid machines. So in classifications of fluid machines, what is the first thing which we are about to discuss? Okay, so first thing, like I will be classifying this fluid machines in a different forms. Okay, so what is the first thing? I'm going to do it based on direction of energy conversion, okay, or energy transfer. So what is the direction in which the energy is getting transferred? Okay, so that is the first classification. In that, based on direction, the first type is the fluid machines which is going to convert, okay, the fluid machines which is going to convert fluid energy. Okay, Fe here is fluid energy, nothing but stored fluids energy. Okay, stored fluid energy. If it is getting converted into, mechanical energy, okay, mechanical form of energy. See, mechanical form of energy, as I already said, in this case, most of the cases, it's nothing but rotation of, we are going to convert it into rotation of shafts. Okay, that is what we are going to mostly do. Fluid energy, which we already seen, such as intermolecular energy, pressure energy, and kinetic energy and potential energy, all those things. If a machine converts fluid energy to mechanical energy, okay, if it converts fluid energy to mechanical energy, then those types of machines are called as, like what actually I am doing, the energy from the fluid is extracted, and it is sent to mechanical energy. That is, I am going to get some work. Okay, I am going to get some work from it. Energy of fluid transferring to mechanical energy. So from shaft I am getting some work. So where I am getting some work, those types of machines are nothing but turbines, right? Turbines, or I can say expanders. Okay, turbines and expanders. Okay, and the second classification is just opposite. I'm not going to write it fully. mechanical energy will be converted into fluid energy. I will use rotation of the shaft. From shaft, energy will be transferred to fluid. Okay, that is I am doing, that is the shaft is doing work on fluid. Those type of machines, okay, those types of machines. There are some examples for this, okay, there are some examples such as pumps, okay, compressor, fans, blowers, etc. Okay, so what is this pumps, compressors, fans, blowers, how it is different, we will see that. Okay, so we will see it in the next classification. Okay, so first classification is how the energy is getting transferred. If energy is transferred from fluid to shaft, okay, from fluid energy to mechanical energy, it is turbines and expanders. If mechanical energy is transferred to fluid energy, it is pumps and compressors, fans, blowers, etc. Let us start the next topic. Next classification of fluid machines, and the next classification of fluid machines are based on what type of fluid you are using. Okay, so what type of fluid you are using, in the sense, again I am going to differentiate this into two different things. One is fluid energy getting converted into mechanical energy. Examples are turbines, expander, those things. Another topic is mechanical energy is converted into fluid energy, which means here I am giving work, here I am getting work. Okay, so I am, in the sense, here I mean that shaft. Okay, the shaft is going to get work, which means the shaft is going to supply work to electrical generator, and the generator is going to give work for us, okay, energy for us. Right, so fluid energy converted into mechanical energy if the fluids used. Okay, the first, if I use water, then the machine is called as hydraulic turbines. More specifically, it is we can say that water turbines, but the word hydraulic will be always used there. Okay, and in this course we will be mostly we will be concentrating on this hydraulic turbines. For gate, hydraulic turbines are very important. Okay, we will be mostly concentrating on that, right, in fluid machineries. And if I use steam, okay, so if I use steam, that is energy of steam is getting converted. Steam is also a type of fluid. If energy of steam is used for converting into work in a shaft, then I will be calling it as a steam turbine, and this will be discussed in thermodynamics, applied thermodynamics. Okay, so applied thermodynamics, which we will be discussing in applied thermodynamics for mechanical student. So you don't have to, the civil students, you don't have to worry about this. Gas turbines, again, if I use any gas or any air, okay, so that type of turbines are gas turbines, and that also will be discussed in applied thermodynamics, so you don't have to worry about it. And winds, okay, so windmills, this we know, right? So due to the wind, the fan of the wind is going to rotate, and from that I am going to get work, I am going to get energy from that. So in all the four cases I will be getting energy from fluid. Okay, so in windmills, we, like, with respect to gate, we are not concerned about this, it's not needed for us, so we won't be studying this in any of the subject. Okay, I am saying about mechanical students, right? And now if you go there, and here in this course, fluid machines course, will be concentrating more on hydraulic turbines only, right? Now come for mechanical energy into fluid energy, where the first classification is pumps. We will be studying about pumps somewhat, not in deep. Turbines will be studying in deep, but pumps we won't be studying in deep in this course. Okay, compressors we will be studying it in, again, applied TD, and blowers and fans we are not going to discuss. Now you might ask me a question. Both compressors, blowers, fans are having gas only. Okay, pumps are nothing but it's going to use liquids, maybe water or some other liquid. But compressors and blowers and fans all are using gas only. But what is the difference in that? Listen carefully. Here itself I mentioned the word high pressure and low pressure for compressor. Compressor for high pressure, blowers and fan low pressure. What actually it means? Let me explain. See, both compressors, blowers and fans are used for converting mechanical energy into fluid energy. If I take fluid energy, totally there are two different possibilities of fluid energy. One is pressure. What I need to do, mechanical energy has to get converted into pressure energy. I need to increase the pressure of the fluid, or else mechanical energy will be used to convert, or mechanical energy will be converted to
velocity, nothing but kinetic energy. Overall there are three energies, right, which we already seen. Kinetic, there are four: potential, kinetic, pressure energy and intermolecular energy. We are not going to increase anyways potential energy. So remaining three, either what I will do, I will convert mechanical to pressure, mechanical energy to pressure energy in fluid, or mechanical energy to kinetic energy in fluid. Why I won't be converting mechanical energy into intermolecular energy or nothing but internal energy. Okay, what is the reason for that? You will understand more clearly once if I discuss thermodynamics, because this is not the place where I need to talk about it, but I will just give a glimpse those who have an idea about it already, because this is not required for civil. You can just not at all required for you. Okay, so for mechanical students, if you already have some idea about thermodynamics, you will understand this, or else not all an issue. We are going to see that in thermodynamics later. Okay, so we will be discussing about thermodynamics in detail in future. Okay, right. So why I am not going to convert mechanical energy into intermolecular energy? Because mechanical energy is nothing but high grade energy, internal energy is a low grade energy. It's not advisable for converting a high grade energy into low grade energy, because the converting back, if I want to convert intermolecular energy into mechanical energy again, I cannot do it 100%. So those who have an idea about thermo, you will understand. Even if you don't understand also, don't have to worry much, because we will be studying about this later. That time you will understand it much clearly. Okay, so for civil students you can leave. So reason why I am not converting mechanical intermolecular energy, because mechanical energy is a high grade energy, okay, or useful form of energy. Intermolecular energy is low grade energy or unuseful form of energy, where the conversion of high grade to low grade is not at all advisable. Okay, because again, if I want to convert it back, I cannot do it. If suppose 10 kilojoule I am converting from mechanical to intermolecular, the same 10 joule I cannot convert it back. Okay, so that is why it is not advisable. So we will remove that intermolecular also. So remaining two, kinetic and pressure. So if overall both compression and blowers are going to transfer mechanical to fluid energy, from mechanical energy to fluid energy, and in compressor I will be increasing the pressure, which means pressure of the fluid will be increased, pressure energy of the fluid will be increased. And in case of blowers and fans, I will be increasing the velocity, which is nothing but I will be increasing the kinetic energy. Example, just think about fan which is there just above you, okay, above your head. What actually it is doing? First, electrical energy converted into rotation energy of the shaft, and that rotation energy of the shaft is getting converted into velocity of the air, right? So why you are like, what is in fact happening? Electrical energy to mechanical energy to kinetic energy of the air. Okay, so that is an example, and you could have already seen compressors. We will be using it anywhere, okay, in many places. So if my want is pressure, if my want is pressure, if I want high pressure, I need to use compressor. If my want is high velocity, that is kinetic energy, then I need to use fans. Right, so these are not very much important with respect to gate exam point of view, but they will be useful in interview point of view, because if you are going to get selected into any public sectors or any MTech or any other interviews, any other good places, then surely you need to cross this interview process. So for crossing this interview process, although all these minute details are very important, especially in hydraulic machineries, there is possibility for questions if you are going to say that fluid mechanics and machineries as your favorite subjects. Okay, so now we will proceed to next type of fluid machines.